will do first is I will think us that we have a common understanding what we mean by a model, what we mean by machine learning, what we mean by this sweet case term, let's say artificial intelligence. But I will go quite quickly over these things because I guess you have some familiarity with these concepts and topics. But if not, then please ask me to slow down, or you can ask questions every time. So first is sweet case term, artificial intelligence. It's a sweet case term because there is no real solution, right? So you cannot, I mean, lately I saw a paper from a guy and he listed, I think, 200 different definitions of AI, so this means there is no definition, but what we can say, or what is useful to say, is that there are 4 schools of thoughts, let's say. I took this from Russell and Norwick textbook, probably the best textbook which does exist right now. Yeah, what happens, or the most movement, let's say, happens in this acting rationally area, where we basically try to train, or where we try to have so-called agents which have a goal, and they try to achieve this goal based on the information they have. And but what we can say is that we can basically we have 2 classes of artificial intelligence. This comes from Ben Goertzel. Who does know Ben Goertzel? So Ben Goertzel is a robotic specialist and a transhumanist, and he proposed that we divide the field of artificial intelligence in 2 different categories. One is artificial narrow intelligence, which means that we have machines that can perform a specific task in a specific domain very well, sometimes even better as humans. And whatever you have read about artificial intelligence, whatever you have seen about it, all these systems, they belong all to this class. Okay? So the left class with artificial general intelligence would be a machine which is basically capable or has the same strength in cognition we humans have. But they have we have quite a broad intelligence. We can do many different things. Machines are not able to do that. So if you train a machine to play Go, or to play chess, or to make coffee, or to recognize objects on an image, it can do exactly that and nothing else. Okay? So, and then we have this hierarchy, let's say. We have artificial intelligence and then machine learning, which is basically the part I will cover today with this bias thing. Is a subset, let's say, of artificial intelligence, and deep learning that is a subset of machine learning. I think that's a fairly useful landscape, let's say, what artificial intelligence is and how you have to sort out somehow things. Okay, so for the machine learning part, I just want to remind you what we mean by a model. So we have 3 different kind of learning methodologies. Let's say we have supervised reinforcement and unsupervised learning. And to be crystal clear here, so probably more than 95% of all applications deployed in the world are supervised learning machine-based systems. And what it is at the end, what we call a model, is nothing else than a joint probability distribution learned over your data and the target label. It's not more. You can call it whatever you want. You can be as smart as you want. But if you train a machine in a supervised fashion, then it's exactly that. So the machine learns a joint probability distribution, and this basically is your model. So you can see also in that way that the machine basically tries to find rules to solve the task, the problem, for example, to detect cats and dogs on an image. And these rules, or you can call it algorithm as well, then is the model. So this is what we call a model. What is worth to mention, I think, is also that if you train a machine, it's inductive. So you train it by example. So it tries to make a generalization out of your examples, but the application then is deductive. So you apply the rules for everything. Like, okay, with a hammer, you go to everything. You do the same. Then the reinforcement learning, it's just that you have an agent. This agent has a goal, and it tries through rewards to learn a policy, to interact with the environment, to fulfill the task it has to. And the model then basically is the agent itself with the state. These are all state-based models. So all these nice achievements from DeepMind with AlphaZero and AlphaGo are of this kind of system, combined with some traditional AI techniques like, for example, Markov chain tree search things, which are not basically in that scope. And the third is this unsupervised. Personally, yeah, people also, I mean, often people tell me that this is a very nice thing, but I seldomly find it very useful, honestly. So the idea is here that you learn somehow patterns. You can use it for dimensionality reduction when you have a data set with, I don't know, 2,000 attributes and you want to shrink it down to 10. You can use this kind of technique, or just to cluster data. It asks you to review the result, because the result can be completely stupid or making no sense, so you have to review the result before you apply then the rules found by the machine. Okay, so that's for the intro, to have a bit of stage, that we have a common understanding what we mean by model, and I think it's always refreshing to remember that mainly in supervised learning, what we do is just we try to find a joint probability distribution and not more. So you can call it whatever you want, but it's that and nothing else. Okay, now so let's start with the bio thing. Who is aware of that? So Amazon tried since years to basically have a more automated hiring process, and they figured out after a while that they couldn't make it really work, because they figured out that women were discriminated by this machine, so that the machine itself, it didn't take into account women as often as it should, based on the statistics you have in the data. Okay? And I mean, this phenomena is not new. For example, in the 80s, in a British hospital, St. George Hospital in London, they had the same problem. And the scandal at that time was not that the machine failed, but the scandal at that time was they basically could figure out, because the machine failed, the machine never basically proposed a woman or a foreigner for the next step in the hiring process. And the machine, of course, was trained based on historical data. So what happened, the machine learned somehow that women and foreigner are anyway not good candidates. And that means that people generating this historical data, they were discriminating women and foreigners. So the scandal at that time was that. And as I remember, you can Google that article. As I remember, some of the management was fired after that, because it turned out that women were discriminated by these people responsible for the hiring process, and the machine basically learned based on the historical data, took that pattern and amplified it. We will see it in more detail how this can happen and what it really means. I mean, you can do your own silly experiment if you go to Google and you basically do this professional haircut and then professional haircut. Who knows it? I mean, this is quite known, basically, or probably not. But if you do that, and if you enter professional haircut and you go to the images, what you see are mainly white young men. Yes, of course, with hair, not like me. But if you do the same with unprofessional haircut, what you see then are dark-colored women. Okay, so you have this is kind of a bias which discriminates not white people. Okay, it shouldn't be like that. Okay, why can't a dark-colored person not have a professional haircut? It makes no sense. Okay? And why this happens, I will explain you a bit later on. But you can do this kind of experiments. For example, if you are looking for a term like beautiful skin, you will get only white women. So there is no Africans who have a beautiful skin there and so on. Why this happens? This happens because people, when they are looking for these kind of things, they mainly click on white women. And basically this pattern then is amplified in the machine. So the machine gets a reward when you click on something. And if most people click on white women, the machine basically is trained not to give out something else. Okay? So the reason basically for all these kind of problems, the reasons are quite simple. The reason are simply the data are biased, and we are biased, and humans generate all these data, right? So, but to find a good solution to solve this problem is quite complex, as I will show. Now, I want to go through with you something we did where we basically detected a bias in the model, in our model, and then we had a dilemma because the more biased the model was, the better was the productivity. Okay, and that.
Quick question, just I don't know if you're going to cover it later, but can we define bias?
Yes, we come to that. We come to that point. Okay. I mean, you have an intuitive sense what bias means. It has to be something fair and so on. It's not bias in just statistical terms. But we come to that. Okay, so we go bit top down. So what we figured out was that we created a model which was quite biased, so unfair. In that case, unfair against female politicians. And yeah, then we had the dilemma because when we removed the bias, the model was not working anymore. And I will explain you why. I mean, it makes completely sense, but there is a danger then in it. So what we used as a model, just as let's say as an overview, is we had quite a complex pre-process thing. So we trained basically. So the idea was that we have 6 million comments online. Now you have to think about that. We have at Immediate 3 persons full-time job. They do nothing else and they read the whole day comments and they say, yes, I can publish this. No, I cannot publish this. So we have about 30% of comments which are not allowed to be published, which also would have legal consequences if we would publish these comments. When we trained, then so the idea was we need a machine which can reduce this workload for the reviewers because the number of comments they increase, and the number of toxic comments, so comments we are not allowed to publish, they increase as well. So we try to make a model which basically reduces the workload. So what we used in that case was quite a complex pre-processing thing. Then we filled it in we did kind of a pre-embedding of the corpus of the words. So we trained that separately, and then we fine-tuned this embedding through a CNN network, where we basically use the width of the window as the context window for specific words. And basically we enrich the whole thing with some one-hot encoded features, so some additional data which we had basically to characterize the comments. And at the end, yeah, you get out a score if the comment is toxic or not. Okay. So that was basically the model. We had 6 million comments, and the results were quite nice. So, for example, if you use the quite high model confidence level, our accuracy was above 95%, and we had a workload or a comment coverage of about 35 or 36%. This was the overall goal of the system that we can reduce. So that means that we can basically reduce the number of comments by about 30%, and we are sure that these comments are correctly classified. Okay? Then we had some nice examples. For example, I mean, this is, for example, this comment. This was reviewed by a reviewer, and he classified it as non-toxic, but he should classify it as toxic. And the thing here is that this reviewer have so much to do that they start to read, and after 2-3 sentences they say, okay, that's okay. Okay. But if the guy would have read the comment to the end, he would see that there are things in the comment which makes the comment toxic, and he should not publish it. So this is an example where the machine, it was easy for the machine to detect it, but the reviewer didn't detect it. Then, I mean, we were quite satisfied with the performance, with the quality of the model, and with the accuracy of the model. Just to say that these numbers, they are based on equilibrium classes. So we have 50% in the toxic and 50% in the non-toxic when we produce these numbers. Okay? So there is no shift in the frequency in the classes. Okay. So then what we basically wanted to know a bit is, what was the thing the model learned, okay? And then we did simple experiment. We started to type a comment, and the machine gave us the confidence that something is, let's say, toxic or non-toxic. And here is an example of C-Sint, okay? And you see that basically these two words are quite neutral, so the machine cannot really determine is it toxic or not toxic. Okay? But when I start to type to bist, then what you see is that the machine is quite sure that this has to be toxic. So of course, if you write more and more and more and more, it will somehow equilibrate. So it will try to balance it depending on what you write. But why happens? Why does this happen? This does happen because after do bis, it's very often followed by an idiot and Volltrottel and Vollpfosten and so on. So, you know, I found words and expressions in these comments I didn't even knew that they exist in German. Okay, so it was really crazy. So, and this basically, from a just model point of view, if you look at the model in an isolated space, it's not good. Why should do bis be more toxic than C-Sint? It makes no sense, right? But from the data point of view, it makes completely sense, because most of the comments with do bis, they have something in it which you have to classify as toxic. Okay. Then we went further and we were looking at, for example, politicians. So gases. So if you start a sentence with gases, it's quite neutral. So the model does not know. Yeah, let's see what comes. Okay. Now if you start with Sommaruga, it's very bad. Okay. Sommaruga is a completely no-go. Now of course, I mean, this is just a showcase. If I start writing Sommaruga hat einen guten Job gemacht, for example, this number will lower and this number will go up, of course, because the machine is not just learning keywords, but it learns the context of words. Okay, that's clear. But this is just to show that also here, from a pure model point of view, it makes no sense that these two different words have a different, basically, score. They should both neutral. Okay, and then we went further. So what we did basically was the following. We took